All right. Hello, everyone. I'm Bernd, and today is day 3 of Advent of Code. Today's puzzle was slightly more complicated in terms of the parsing, but yeah, so what was it about? We have an engine, and the engine looks, or schematic looks something like this. We got a few multi-digit numbers, like this one or this one. And then for the first part, we care whether adjacent to a number there is a symbol or not. So for this symbol number, for example, there is this star symbol adjacent to it, so we also count diagonal. Similarly for this 35, we have a number symbol adjacent to it. For this 114, note there is no symbol adjacent to it, so the dot does not count as a symbol, just everything else. And yeah, so then to get the solution, we just sum up all the values or all the numbers which do have a symbol adjacent to it, and that will be a solution. All right, so let's look at some Python code to do this. So what we need to do in order to solve this problem, of course, we need to be able to read the input by reading the file and splitting it into lines. And then what will be useful is to have a class which represents a position. So it just as an x and a y coordinate, and then we'll define some lambda methods to do some standard operations, like we want to be able to add two positions by adding their coordinates. We want to check if two positions are equal by checking both their coordinates. And we also want to be able to hash a function in order to use the position as a key in a dictionary. And then the grid will represent as a dictionary. So the keys will be positions, and then it will give us the corresponding character as a string. And in order to parse the lines, so we want to convert a list of lines into a grid. We just go through the lines and enumerate in order to give us the line index that we stored in the y character. And then we're going to go through each line, also enumerate to give us the position within the line, and as well as the character. And then we just set the grid at the corresponding position with x and y coordinate to be equal to that character. And that will give us a dictionary, which we call the grid. For this problem, we care about finding neighboring positions, so it will be useful to define some methods to find neighbors. So in particular, first, we want to define neighbor directions. So if you have a point and all the 8 dots around it would be potential neighboring positions, so the direction would be this vector, and so on. So how can we define all these 8 vectors? We just iterate the change in x coordinate to be -1, 0, and 1. We also let y be -1, 0, and 1, and have all of those combinations, apart from the one where both are 0, which would correspond to the position itself and not be a neighbor. So this defines this 8 vectors, which correspond to the 8 neighboring positions. And that will be useful, for example, in order to get the neighbor of a position. So when we want to get the neighbor of a position, we want to also consider the grid, because the neighbor is supposed to be in the grid and not outside it. So if the position is on the border of the grid, we don't want to go outside the grid. How can we get that? So essentially we consider all this neighbor direction and add them to the position. So for each direction in a neighbor position, we add it to the position to the direction to the current position. And before that, and we also check if this new position is within the keys of the grid. So it's a legal position in the grid. And that will give us all the legal neighbor of that particular position in a grid. We want to have a slightly more general function to get the neighbors of not a single position, but a set of positions. So there we can use this previous function. So essentially we go through all these positions in the set of positions. Then the local neighbor will be the neighbors of the position in the grid. And then we update the whole set of all neighbors to also contain the local neighbors. And then we definitely added all the neighbors to the set, but we added a few positions too many. So in particular, we added all the positions that were in the original set. We added those we might have added those to the neighbors as well. So we subtract that again to get the real neighbors and not the positions itself. Okay, so that's some kind of boilerplate code to get a grid and processes and find neighbors. In the grid, we want to care about these numbers, and we're going to care about the numbers. We also want the position, so that's just a small class that we could also use the name tuple or so. That just saves the value and the set of positions for a particular number. So that will be for a 3-digit number, would be 3 positions. And then we need to somehow parse those numbers with positions out of the set of input lines we're given. So if we So in order to find the numbers in a list of lines, we just go through each line individually and find the numbers in this line and then collect them all into one long list. So maybe that's interesting code to find a number within a line. So essentially a line might look something like this. So we have one number here and another number here, and we want to find those numbers. Maybe we could use some regular expressions or so, but in this case I just coded it out. So we start with the current position as 0, and then while the current position is smaller than the length of the line, so that's why it's a legal position. At first we check if the line at the current position is not a digit, then we kind of ignore that and like it increments x by 1 and continue. Otherwise, if it is a digit, we know we kind of want that's the place where new numbers start. So first we find the length of the number in the line at starting position x, and then we can calculate the value of this number by just looking at the substring starting at x and ending at x plus length, or ending at x plus length minus 1, and converting it into an integer. And similarly, we can also get the set of positions that this number has by just taking the current position plus I for I in 0, 1, 2, and so on until length minus 1. And the y position will be the line number, which we will apply to this function. And this allows us to define the new number as by storing the value as well as the set of positions it takes, and adding that to the list of numbers. And then importantly, we want to increment x not just by 1 but by the length in order to not count the number twice or count the subset of the number as a new number. So this function is a little bit complicated. So we want to test that it actually works. So we wrote a little test. So that would be our line, and then we want to call this find numbers in line function. And first of all, we want to check that it actually gives us two numbers. So there's clearly two numbers in this line. And then we check that both of the numbers are correct. So the first number should have value 467, should have 3 positions, and this should be the 0 zeros, 1 0, and 2 zeros should be in the positions. Similar for the second number, the value should be 114. It should also have 3 positions, and these 3 positions should be in the positions of the number. So we can check that. That looks good, so I can kind of be confident that this find numbers in line actually works. Not 100% sure, but that at least gives us some confidence. Okay, yeah, and in order to find the length of a number, we also needed that. We just go from a starting position, start with length 1, and then look at the next character. So the next character will be starting position plus length, or this will be the index, and then the line will tell us the character. And we check if the next character is a digit. That's good, we can increase the length by 1. If it's not a digit, we know that's where the number ends, and we return the corresponding length. Okay, with that we can solve the problem. So we start with a list of lines, and then first we find all the numbers in those lines, whether the function we defined before, and then we also use these lines to convert it into a grid to be able to easily access the characters at positions based on their position. And then we find the solution by going through all those numbers we found, and then we check if the number has an adjacent symbol in the grid, and then we add the number value to the solution as we are being told. In order to evaluate whether a particular number has an adjacent symbol in the grid, of course, first maybe we need to know what if a character is a symbol. So by definition, character is a symbol. If it's not a digit and not the dot character, so essentially if it's a digit or a dot character, we return false. It's not a symbol, otherwise we return true. And then with that, we can check whether a number has an adjacent symbol in a grid by just first getting all the neighbors of the positions of the set of positions of the number, and then going through all the neighbors and checking if at the neighbor position in the grid, the corresponding character is a symbol. If that's the case for one of them, we return true. If it's not the case for all of them, we return false. All right, so with that, we can also test the whole solution on the test input we have. And with a bit of luck, that looks good, gives us the right solution. So we can also test on the real input, and it also turns out it gives us the right solution. Okay, for part 2, we mostly care about the star symbol. So again, in the same grid, we want to look at all the star symbols and count how many numbers are adjacent to each star symbol. So in this case, for this star symbol, it would be this number and this number. Again, we count diagonally as adjacent. And then we want to know for all of the stars which have exactly 2 neighbors will contribute to the solution. And if they have 2 neighboring numbers, we multiply the corresponding values together and add that to this, and that will be the solution, the sum of all those products. Okay, so how can we do that in code? We can reduce a lot of code from part 1, in particular the read input function, the function to find the numbers within the lines, the number function to convert the lines into grid, and also the function to get the neighbors from a particular position. In order to solve part 2, we will first again parse the line to find all the numbers in the line, and then we'll also convert the lines into this grid dictionary. And then what we want to do, or what will be helpful, is to have a dictionary that maps each position to the corresponding number that is at this position, if there's a number at this position. So how can we create such a dictionary? So essentially we go through all the numbers and we'll enumerate them. So we have the number ID, and then go through a position of the number that the number occupies by calling this position property, and then for each of those positions we'll map this position to the corresponding number ID. In order to find out the solution, we will consider all the positions in the grid, and then if the character at this position is not equal to the star, that does not contribute to the solution, so we continue. So we only consider here all the positions that have a corresponding star at the corresponding in the grid. And then for this position, we want to evaluate all the neighboring numbers and all the IDs. Like the ID would just be the index in this list of the neighboring numbers. So that we're gonna go through all the neighbors of the position within the grid. And then for each of those neighbors, we check if at this neighboring position there is a number. So in particular, that would mean that in this position to number ID dictionary, the neighboring position is a key. And if that's the case, we add the corresponding number ID to this set of positions. So that's also why we use the number ID, not the number, because then we can use them within a set. Yes. Then, once we have found all these IDs of neighboring numbers, we can check if there's exactly 2 of them, then that is interesting and that contributes to a solution. So we consider the first neighboring number and the second neighboring number, we calculate their values, and then the solution or the amount it contributes to the solution will just be the product of the values. And that will give us the solution. We can test it on the test input, of course. That looks good. So we can also run it on the real input, and it also turns out that gives us the right solution. All right, I hope you enjoyed today's puzzle, and best of luck for the future, and see you around.